Okay, for our second lesson, let's talk about linear equations, functions, and inequalities. So we'll start out with a bit of a review, just solving some linear equations. We have 3x plus 1 equals 7. So when we say solve this equation, what we're meaning is we want to find a value of x that will make this a true statement. Okay, so what number can I plug in for x so that 3 times that number plus 1 will equal 7? So what we want to do is do something to both sides of this equation, do the same thing to both sides. So in this case, I'm going to subtract 1 from both sides of the equation. 1 minus 1 is 0, and then 3x plus 0 would just be 3x. And over here, 7 minus 1 is 6. So I just subtracted this 1 from both sides. Okay. Now to get rid of the 3 and isolate the x, I want to divide both sides by 3. So I have 3x equals 6. I'm going to divide this side by 3, and I'm going to divide this side by 3. 3 divided by 3 is 1. So I'm left with 1x, or just x equals 6 over 3, and we can reduce that and get 2. Okay, so we're saying that the value of x that makes this statement true is 2. So let's check that. If I plug 2 in for x, I should get a true statement. So check that 3 times 2 plus 1 is really equal to 7. 3 times 2 is 6. 6 plus 1 is 7. I've got 7 is equal to 7. So that's a true statement, and we know we got it right. The next one, 2x minus 5 equals 4. To get rid of the 5, since it's minus 5, we want to add 5 to both sides. So if I add 5 to this side and add 5 to that side, I'll have 2x equals 9. To get rid of the 2, I'm going to divide both sides by 2. And that will leave me x equals 9 over 2. And again, let's check that and make sure it's really correct. So I'm going to check that 2 times 9 over 2 minus 5 is really equal to 4. Okay, so if I do 2 times 9 over 2, let's put a 1 under that 2. And we can simplify there. Those are 1s. 1 times 9 is 9. 1 times 1 is 1. So I get 9 minus 5 equals 4. 9 minus 5 is 4. 4 is equal to 4. And we know we got it right. Okay, let's try this last one. Okay, this has fractions in it. Don't be scared by fractions. We'll do the exact same thing. So to get rid of the 1/2, I want to subtract 1/2 from both sides. So I'm going to subtract 1/2 on this side, subtract 1/2 on that side. I'm going to come over to the side and do some scratch work out the fraction part of it. So I have to do 4 minus 1/2. Over here, 4 minus 1/2. In order to add or subtract fractions, I need a common denominator. Okay, so let's put a 1 under this. My common denominator can be 2. So I need to multiply by 2 on the top and 2 on the bottom. And that'll give me 8 over 2 minus 1 over 2. I now have a common denominator. 8 minus 1 is 7. And the denominator stays the same. So 4 minus 1/2 is 7 over 2. So I have negative 3/5 x, those cancel away, is equal to 7 over 2. Now I need to divide both sides by negative 3/5. Dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So I'm going to multiply both sides of this equation by negative 5 over 3. So multiply that side by negative 5 over 3. And I'm going to multiply this side by negative 5 over 3. Here, if I multiply, I'll get 15 over 15, which reduces to 1. Or you could also think that those cross out, and I'm left with 1. So I've got x equals negative 35 over 6. Good. All right, we should always check our answer and make sure it's correct. So I'm going to plug negative 35 over 6 back into x and see if this is a true statement. All right, so if I do that, I'll have negative 3/5 times negative 35 over 6 plus 1/2. And we're going to see if that's equal to 4. All right, so we got to multiply these. Now we could just multiply straight across the top, straight across the bottom. We could do 3 times 35, and we could do 5 times 6, but those numbers are a little big, and I don't want to deal with that. So let's simplify everything we can. So here, if I reduce the 3 and the 6, that'll be a 1, that'll be a 2. 3 over 6 reduces to 1/2. I can simplify these guys. That'll be a 1, and that'll be a 7. Then I can multiply. Negative 1 times negative 7 is 7. 1 times 2 is 2, so 7 over 2 plus 1/2. And we want to know, is that really equal to 4? So add or subtract fractions, I need a common denominator. I've got one. 7 plus 1 is 8 over 2. And we want to know if that's really equal to 4. 8 divided by 2 is 4. So it really does, and we know we got the right answer. All right, let's talk about inequalities. So this expression says that 3 is less than 5. That's true. 3 is less than 5. What if we add something to both sides of this inequality? So say, for example, we add a 2 to both sides. So 3 plus 2 less than 5 plus 2. Is that true? Well, this is 5, and that's 7, and you see that it's still true. Let's imagine something else. Let's add, let's say we add 8. Let's add 8 to both sides. So 3 plus 8 is 5 plus 8. 3 plus 8 is 11. It's 13. 11 is still less than 13. So if you think about it, you can see that if I add anything to both sides of an inequality, to a true inequality, true statement, it'll still be true. And if one number is less than another, and then I add the same thing to both of those numbers, the one on the left will still be less than the one on the right. So if you have an inequality, you're always allowed to add some number to both sides, and it'll still be a true statement. What about subtracting a number from both sides? So let's say that we have, same example again, 3 is less than 5, that's true. Let's subtract 1 from both sides. So let's do 3 minus 1, 5 minus 1. 3 minus 1 is 2, 5 minus 1 is 4, 2 is still less than 4. So if you think about it for a minute, if you have one number, say the number on the left is less than the number on the right, and you subtract the same number from both of those, the number that you're left with on the left will still be less than the one that's on the right. Let's try greater than. So 7 is definitely greater than or equal to 2. That's true. What if we add the same number to both sides? Will it still be true? So let's say 3. So 7 plus 3 equal to 2 plus 3. 7 plus 3 is 10. That's 5. You can see that the one on the left is still bigger than the one on the right. And that's true. If you think about it, if you have two numbers, one number is greater than the other number, and then you add the same number to both sides, the one over here will still be bigger than the one over here. Okay, let's think about multiplication. So let's just use this same example. What if I multiplied both sides by the same number? Will it still be true? So let's multiply both sides by 3. Is it still true? 7 times 3 is 21. And that's 6, and 21 is still bigger than 6. So that's true. I multiply both sides by 3, still bigger. If I multiply both sides by 5, let's say, it would still be true. What if we divided both sides by a number? So here is a true statement. 10 is really less than or equal to 12. What if I divide both sides by 2? 10 divided by 2. 12 divided by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. And 5 is still really less than or equal to 6. Okay, so far so good. Let's try this though. Let's do our same example here. What if I multiply both sides by -3? Seven times -3 is -21. 2 times -3 is -6. And is it still true that -21 is greater than or equal to -6? Is that true? That's not true anymore, is it? -21 is not bigger than -6. I would much rather be $6 in debt than $21 in debt. So something went wrong. So notice that we multiplied both sides by -3, and that caused this to be false then. So it started out true, and multiplied by -3, and now it's false. What would be a true statement is if we wrote this the other way around. If we did that, if we flip this inequality sign, now it's true. Okay. And that's always going to hold. If I have an inequality and I multiply both sides by a negative number, I'm going to have to change the way that my inequality points. I'm going to have to flip it. Because if I don't, it's going to be a false statement then. Okay, let's look at another example. So 5 is really less than 7. That's a true statement. Let's multiply both sides by a -2. So 5 times -2 is 7 times -2. So I get -10 and I get -14. Now, which way does the inequality point? Which one of these numbers is smaller? -14 is less than -10. So now it should point this way. -10 is greater than -14. So multiplying both sides by a negative number causes my inequality to flip directions. I started out less than, flipped it to a greater than. What about if we divide by a negative number? So 8 is less than 10. That's a true statement. 8 is less than 10. Let's divide both sides by -2. I get -4 and I get -5. Which way should my inequality point now? -5 is less than -4. So -4 is greater than -5. So notice that my inequality flipped directions. So if you start with a true inequality, if you multiply or divide by a negative number on both sides, you have to change the way your inequality points. You have to flip it. Okay, so let's review that. If you have a true inequality, you are always allowed to add or subtract the same number to both sides of that inequality. you're always allowed to multiply or divide both sides of an inequality by any positive number. However, if you multiply or divide an inequality by a negative number, you have to change the way that the inequality points. You have to flip it. All right, let's solve some linear inequalities. So the first one here, I have 2x plus 5 is less than or equal to 13. So I want to know what values of x will cause this to be a true inequality. So I'm going to subtract 5 from both sides of the inequality. Am I allowed to subtract a number from both sides of an inequality? Yes, I am, so I can do that. That'll leave me with 2x is less than or equal to 8. I need to divide both sides by 2. 2 is positive. Am I allowed to divide both sides of an inequality by a positive number? Yes, I am. So let's do that. So this says that any x that's less than or equal to 4 should make this a true statement. So let's represent that solution set on a graph. So here's 4. Less than or equal to, so x could equal 4. So I'm going to put a closed circle right there. And I'm going to shade in every number that's less than 4. So all of these numbers out this way forever and ever. Okay, so what I'm saying is that any number that's less than 4 or equal to 4 should make this be a true statement. So let's check some and see. Let's check 4 itself. If I put 4 in here, 2 times 4 is 8. 8 plus 5 is equal to 13. So that's true. So I'm colored in. Let's try, say, a 3. If I put a 3 in, 2 times 3 is 6. 6 plus 5 is 11. 11 really is less than 13. So that's true. Let's try, say, a 0. If I put in a 0, 2 times 0 is 0. 0 plus 5 is 5. 5 really is less than 13. So that's good. Let's do maybe a negative 1. If I put a negative 1 in, 2 times negative 1 is negative 2. Negative 2 plus 5 is 3, and 3 really is less than 13, so that's true. So if I plug in any of these numbers out this direction, they will all result in a true inequality. Let's check one on this side. Let's go with 5. So if I put a 5 in right here, 2 times 5 is 10. 10 plus 5 is 15. 15 is not less than 13, so that's not true. Okay, so none of these numbers out this way are going to make that true. So we've shaded in all the solutions to this inequality. Another way to represent these answers. Let me get rid of all the stringy stuff. So this is representing the solution set on a number line. Let's also talk about interval notation. Okay, so interval notation.
Preston Seals to the office to go off, please.
It looks like an ordered pair, but it's really, I'm going to put my smallest number here and my biggest number here. And this includes, or my solution set from whatever my smallest number is in my solution set all the way to the biggest number. And notice that my solutions go all the way out forever this way. We're going to represent that with negative infinity. And always I'm going to put a parenthesis on an infinity. And my solutions go from negative infinity all the way up until I get to 4. And that's where they're going to stop. My 4 is included, so I'm going to use a square bracket. And so what this means is all the real numbers from negative infinity to 4, and the 4 is included. So from negative infinity, as far out that way as I can go, all the way to negative, or all the way to 4, and the 4 is included. All right, let's solve another one. So I'm going to add 3 to both sides. Am I allowed to add or subtract a number to both sides of an inequality? I am, so let's do it. 4x greater than 8. Divide both sides by 4. Am I allowed to divide both sides by a positive number? Yes, I am. So let's do it. X is greater than 2. Okay, let's represent these solutions on a number line. There's 2. I want to graph all the solutions, or all the x values that are greater than 2. So numbers that are bigger than 2 are out in this direction. This time I'm not going to include the 2. My solution can't be equal to 2. So I'm going to represent that with an open circle. So this means all the numbers that are bigger than 2, but not including 2. So 2.1 is in my solution set. 2.01 is in there. 2.0001 is in there, but 2 is not. Let's check some just to make sure we're really right. So take 3. So I've shaded in 3, so 3 better make this true. So if I put in a 3, 4 times 3 is 12. 12 minus 3 is 9. And 9 really is bigger than 5. Okay, so all these numbers out this way will work. Let's check one over here and see if it works. So let's put in, say, a 1. If I plug in 1 for my x, 4 times 1 is 4. 4 minus 3 is 1. And 1 is not bigger than 5. So that won't work. So none of these numbers out this way will work. All the numbers out this way will work. Let's represent this solution set in interval notation. So this time my smallest number is 2. And I go from 2 all the way this way forever and ever. So I'm going from 2 to positive infinity. I always put a parenthesis on an infinity. And this time, is the 2 included in my solution set? No, it's not. So I'm going to use an open parenthesis like that. So an open parenthesis means it's not, that number is not included in the solution set. A square bracket means that that number is included in the solution set. All right, let's try a couple more examples here. So let's solve this inequality. So the first thing I'm going to do is subtract 1 from both sides. I'm allowed to do that. That'll leave me with negative 5x less than or equal to 15. Right, now I need to divide both sides by negative 5. You've got to be careful when you do that. Anytime you divide or multiply both sides of an inequality by a negative number, you have to change the way that inequality points. So if I divide both sides by negative 5, I'm going to get x is greater than or equal to negative 3. Okay. So again, if you multiply or divide both sides of an inequality by a negative number, you have to change the way that inequality points. So that should be my solution set. Let's represent that solution set graphically on a number line. Here's negative 3. I want to shade all the numbers that are greater than or equal to negative 3. So equal to negative 3 is there. Shade all of these guys. All right, well, let's check, make sure we got it right. So I'm going to just pick some number over here that's bigger than negative 3. Say 0. 0 is really easy. Or 0 may be too easy. Let's put in something a little harder. Let's do a 1. Okay, so if I put a 1 in, negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. Negative 4 really is less than 16. So I got it right. Let's check over this way. So let's do maybe a negative 4. Okay, so if I put in a negative 4, it shouldn't work. So I'm plugging in something over here. It shouldn't work. Let's make sure it doesn't work. So if I put in a negative 4, negative 5 times negative 4 is 20. 20 plus 1 is 21, which is really not less than negative 16. So we can be confident we got that right. Let's write it in interval notation. So my smallest number is negative 3. Negative 3 is included in the solution set, so I use a square bracket. And I'm going to go from there all the way to infinity, which always gets an open parenthesis. All right, let's try one more example. All right, so to solve this, I'm going to subtract 2 from both sides. That's okay. I can always add or subtract any number, positive or negative, from both sides. So that'll leave me with negative 3x is greater than 5 minus 2 is 3. I'm going to divide both sides by negative 3. I'm dividing by a negative number, so I have to change the way my inequality points. So that'll be x is less than negative 1. Let's represent the solution set graphically. Here's negative 1. I'm not going to include the negative 1, so I'm going to put an open circle. I'm going to shade everything that's less than negative 1. So those numbers are to the left, not this way. Let's check and see if it makes sense. Let's put a 0 in. So if I put a 0 in, it should not work. If I put a 0 here, 3 times 0 is 0. 2 minus 0 is 2, and 2 is not bigger than 5. So that's cool. Let's put in a number here, see if it does work. Let's do negative 2. If I put a negative 2 in for x, I'll have 2 minus negative 6. So that'll be 2 plus 6, which is 8, and 8 really is bigger than 5. So we're good on that. All right, so here's another linear equation. This one's a little bit different. In the previous examples, we had one unknown in it, or one variable. In this one, we've got 2 variables. We've got an x and a y in there. All right, we want to find solutions to this equation. So there's going to be more than one solution to this. All right, so by solution to an equation with 2 variables, we mean that we want an x value and a y value that'll make this true. So let's see if we can find one. And we'll write it as an ordered pair. So pretend that x was, say, 1. Okay. If x were 1, then 3 times 1 is 3. 3 minus 1 is 2. My y would have to equal 2. Okay. So this is a solution to that equation. If I put a 1 in for x, y would be 2. Let's try another one. Let's put a 2 in for x. If I put in a 2 for x, 3 times 2 is 6. 6 minus 1 is 5. So y would equal 5. Let's put in a 3. Let's put in a 3 for my x. If I put in a 3 for x, 3 times 3 is 9. 9 minus 1 is 8. And let's put in a 4. Put in a 4 for x. 3 times 4 is 12. 12 minus 1 is 11. And I got another solution. Let's put in a 0. Zeros are always good. If I put in a 0 for my x, 3 times 0 is 0. 0 minus 1 is negative 1. Let's put in negative numbers. Let's do a negative 1. So if I put in a negative 1 for x, what does the y have to be to make this a true statement? So 3 times negative 1 is negative 3. Negative 3 minus 1 is negative 4. Okay, so I can put in any number I want for x, and I would be able to figure out what the corresponding y needs to be. So I've got an infinite number of solutions here. I can put in fractions for the x. I could put in irrational numbers. I could put in any real number I want, and I would get a y value out of it. Okay, let's make a graph of all the solutions to this equation. I'm going to put my x values on the horizontal axis and my y values on the vertical axis. So let's see. 1, 2, 3, 4. That'll be enough of those. 4. Let's go 5. 1, 2, 3, 4, 6, 7, 8. That high. All right, so let's make a graph of these solutions. My first one, my x is 1, my y is 2. So 1, 2. I've got 2, 5. 2 and 1, 2, 3, 4, 5. 5 is there. I've got 3, 8. 3, 8. There. I've got 4, 11. And that won't fit on my drawing here. I didn't plan that out well enough. All right, I've got 0, negative 1. That would go here. And I've got negative 1, negative 4. That would go about right there. And you can see then that these all lie on a straight line. We can plug in fractions. So what if I put in, say, 1/3? Okay, so right there's 1/3. If I put a 1/3 in for my x, 3 times 1/3 is 1. 1 minus 1 is 0. So I would have a dot there. What if I put in maybe 1/2? Or I put in 1.5. So if I put in 1.5, I would be able to work it out and I would get a number right up in here. So I'm allowed to plug in any of these numbers I want for x, and I'll always get a dot somewhere right in there on that line. So since I will always get an answer, I'm allowed to connect all of these dots like that. And by connecting them, drawing a line through them, what I'm meaning is that every point on this line is a solution to that equation. There's an infinite number of points on this line. There's an infinite number of solutions to this equation. Every point on this line is a solution to that equation. Notice it makes a straight line, hence this is called a linear equation. Okay, so in our last lesson, we talked about the slope of a line. So imagine we have a line with a positive slope. So it's increasing from left to right. If your line has a positive slope, will it have to cross the y-axis somewhere? So think about that. If it has a positive slope, so if your line is slanting uphill like this, will it cross the y-axis at some point? It would, wouldn't it? What if it's slanting downhill? And so I've got a line that's decreasing from left to right, negative slope. Would it have to cross the y-axis at some point somewhere? Yeah, it would. What if you had a zero slope? So a horizontal line, would it cross the y-axis somewhere? It would. So what's the only kind of line you can draw that would never touch the y-axis? Okay, so the only way you can draw a vertical line to never touch the y, well, I just gave it away. The only kind of line you can draw that would never touch the y-axis would be a vertical line. And vertical lines have undefined slopes. Okay, so for instance, I could draw a vertical line here, and it would never touch the y-axis. Okay, but it has an undefined slope. So if your line has a slope that is defined, then it'll have to touch the y-axis at some point. Okay, so let's just call that point where it crosses the y-axis B. Okay. So it crosses the y-axis at B. And let's just draw some random arbitrary line. Looks like this. So just any old line, it crosses the y-axis at B. All these points on the line are xy values. So just some arbitrary point, let's call it xy. So just any point on the line, xy. It's going to go through the y-axis somewhere. Let's call that point where it goes through the y-axis B. What's the coordinates of this point then? The x value is 0, so this would be 0, B. All right, just like we did in the last lesson, let's find the slope of this line. So slope is equal to y2 minus y1, so y minus b, over x2 minus x1, so x minus 0. All right, I don't want to have to write slope every time, so let's come up with an abbreviation. Let's abbreviate slope with an M. Everybody abbreviates slope with an M. I have no idea why, but that's the way it's done. M is going to stand for slope. So we got y minus b. Let's simplify here. X minus 0 is just x. Let's solve this equation for y now. So to solve this for y, I'm going to multiply both sides of the equation by x. So I'm going to multiply this side by x, this side by x. So times x and times x. When I do that, those x's cancel. And I'm left with m times x equals y minus b. I want to solve for y, so I'm going to add b to both sides. I'll have mx plus b on this side, and I'll have y on that side. You all probably seen this equation before. This is the equation of a line. So the equation of a line. Y equals mx plus b. So any equation in that form will be a linear equation. When you graph it, it will make a straight line. The m stands for slope, and the b stands for your y-intercept, because that's what we made it over here. All right, let's graph this equation. And by graphing the equation, I mean graph all the solutions to that equation. One way we could do it is to just find the solutions, find some solutions like we did a few minutes ago. We could plug in any number we want for x, figure out what the y needs to be, plot all those points. However, now we have an equation of a line, y equals mx plus b. So we know that this is the slope. It's the slope. And we know that this is the y-intercept. Y equals mx plus b. And this, of course, is the same thing as plus -2. All right, so if I know what my y-intercept is, or my b, I can just go ahead and graph it. So the y-intercept of my equation will be at -2. The slope is 3/5. And remember, the slope is the change in y over the change in x. Okay, so it's my y2 minus y1 over x2 minus y2 minus y1 over x2 minus x1. So the change in y on the top, the change in x on the bottom. So since there's a 3 on the top, that says my change in y is 3. So that means from this dot to the next, to another dot, I need to go up 3. So up 1, 2, 3. Change in x is 5, so I need to go right 5. 1, 2, 3, 4, 5. So I started at this dot and I went up 1, 2, 3, and I went over 1, 2, 3, 4, 5. And then I can just connect those with a line, because every point on that line is a solution to that equation. And now I've graphed that equation. Let's check and make sure we really got this right. So we're claiming this point is a solution to that equation. This point is 5, 1. This point is 0, -2. Let's check and make sure those really work. So if I put a 5 in for the x, my y value should equal 1. So if I put a 5 right here, 3/5 times 5, 5's would cancel and I would just be left with 3. 3 minus 2 is 1, so that works. Let's put in a 0 for the x. 3/5 times 0 is 0, 0 minus 2 is -2, so that works. All right, let's try another example. So again, I have an equation, and this has the form y equals mx plus b. So my slope is -2, and my y-intercept is 5. So I'm going to plot the y-intercept, 1, 2, 3, 4, 5. My slope is -2. So let's put a 1 underneath that -2. -2 over 1 is the same thing as -2. So this says now that my change in y is -2. My change in x is 1. Okay, so that means I should go down 2 and right 1. So I'm going to start at this, go down 2, and right 1. My change in y was -2. My change in x was 1. And then all the points in between there would also be solutions. So we would have a line that looked like that. All right, let's look at another example of a linear equation. So we want to find some solutions to this equation and make a graph. Okay, so we can put in any number we want for x, or we can put in any number we want for y. Let's put in maybe a 1 for the x. So if I put in a 1 for my x, then I'll have 3 times 1 is 3. And let's write this out over here. So I'm putting in a 1 for my x. 3 times 1 is 3. I have 3 plus 4y equals 24. Subtract 3 from both sides, I get 4y is equal to 21. Divide both sides by 4, and I get 21 over 4. I could also put in any number I want for the y. So, I don't know, let's try maybe a 2 for the y. So if I do that, I'll have 3x plus 4 times 2 equals 24. That'll be 8. So 3x plus 8 is equal to 24. Subtract 8 from both sides. And 3x is equal to 16. And divide both sides by 3. I get x is equal to 16 over 3. Okay, so those are two solutions. Let's see if we can put in a number for x and y that will give us a nicer answer than these fractions. So let's put in a 0 for the x. Remember, we can put in any number we want for x or any number we want for y. Some numbers you plug in might make your answers prettier than others. So always try to be clever about the numbers you plug in. So if I put a 0 for my x, 3 times 0 is 0, and I'm left with 4y equals 24. So if I got 4y is equal to 24, divide both sides by 4, and y should be 6. So 0, 6 is a solution to this equation. Let's try putting in a 0 for the y value. So if I put in a 0 for y, 4 times 0 is 0. So I'll have 3x equals 24. So x would have to be 8. So there's 2 more solutions. So we have 4 solutions there to this equation. There are an infinite number of those solutions. Let's make a graph. Let's plot the 2 really easy points. Let's plot 0, 6. That goes here. And let's plot 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. We know there's an infinite number of solutions, so I'm allowed to connect these dots, points, and I'll get a line that looks like that. Let's check our other 2 solutions and make sure they're actually on this line. So 1, 21 over 4. 21 divided by 4 would be 5 and 1/4, because 4 times 5 is 20, and I got 1 left over. So 5 and 1/4. So if I plug in 1, I should have a point at 1, 2, 3, 4, 5 and 1/4, which is about right there. So this point is 1, 21 over 4. Also, we have 16 over 3, which is 5 and 1/3. So if my y is 2, then 1, 2, 3, 4, 5 and 1/3, about right there. 16 over 3, 2. So again, we can find an infinite number of such solutions on there. All we have to do is plug in any number we want for x, say 3, and we'd be able to figure out what the y value is. All right, a second way we could graph this equation is to write the equation in slope-intercept form. And slope-intercept form means the form where you can see the slope and the y-intercept. The slope and the y-intercept. You know that form already. We talked about it a few minutes ago. That's y equals mx plus b. M is the slope, b is the y-intercept. So to do this, we want to just solve the equation for y. So I'm going to move the 3x to the other side by subtracting 3x from both sides. So if I subtract 3x from this side, I'll be left with 4y. If I subtract 3x from this side, I'll have negative 3x plus 24. Then I can divide both sides by 4. So y equals negative 3x plus 24, all divided by 4. You have to divide this whole entire side by 4. This 4 can both go with both of those terms. So I will have negative 3/4 x plus 24 divided by 4 is 6. So the 4 goes with both terms. So now you can find your y-intercept is 6 and your slope is negative 3/4. So let's plot that over here. My y-intercept is 6, just where we said it was. And the slope is negative 3/4. So we should go down 1, 2, 3 and over 1, 2, 3, 4. And we have the point right here. So this point would be 4, 3. Well, we went down 1, 2, 3, so we're now at 3. And we went over 4, so we're now at 4. Let's check and make sure this is really a solution. I should be able to plug in the 4 for the x and 3 for the y. So if I put a 4 for the x, that's 12. 3 for the y, that's 12. 12 plus 12 is 24. So that looks good. From this point, if we went down 3 and over 4, if I go down 3, I'll be here. And if I go over 4, I'll be here. And we find this next point on the line. So 2 ways to graph this equation. You could plot points, plug in some clever numbers that'll make it work out easily. Or you can put it in slope-intercept form and then plot the y-intercept and use the slope to find another point. All right, so let's make a graph of the solutions, of all the solutions to this inequality. Okay, so the first thing we're going to do, let's take the equals part. Y equals negative 3x plus 5. So my y-intercept is at 5. My slope is negative 3, so I would go down 1, 2, 3, over 1. There's another point. And let's draw that line. Okay. So that line contains all the solutions to y equals negative 3x plus 5. But we also want to graph all the solutions for the less than part. So let's take a point in particular. Let's just pick one here. Let's do the point 0, 0. Let's figure out if 0, 0 is a solution to that equation. So if I put in 0 for x and 0 for y, let's see what happens. So I'm going to put a 0 for the y I'm going to put a 0 for the x. Negative 3 times 0 is 0. 0 plus 5 is 5. Is that true? Is 0 really less than or equal to 5? It is. So this point is a solution to that inequality. Let's try another point. Let's do the point 0, 2. Okay, so if I put in a 0 for the x and a 2 for the y, let's see if that's true. Okay, so y is 2. Is that really less than or equal to, put a 0 for the x? 5 is 2 less than 5. It is. So that's a solution. Let's try this point here. Let's do 1, 1. Okay, so if I put a 1 in for the x and 1 in for the y, I will have 1 is less than or equal to. Put a 1 in for the x, and I get negative 3 plus 5 is 2. 1 really is less than 2, so that's a solution. And in fact, if you plotted any point on this side of the line, it would be a solution to that. So what we're going to do is shade in. It's really hard to shade things on a whiteboard. It's much easier if you do that on paper. We're going to shade in all the points over here. So every point on that side of the line is a solution to that inequality. Let's just check a point over here and see if it works. So let's pick maybe this point right here. Okay, let's say that this point is 5, 1. And let's see if 5, 1 is a solution to that inequality. Okay, so I'm going to put a 5 in for the x and a 1 in for the y. And let's see what happens. So 1 for the y, put a 5 in for the x. Negative 3 times 5 is negative 15. Plus 5 is negative 10. Is 1 really less than or equal to negative 10? It's not. So that would not be a solution. Not a solution to that inequality. So if you check any point on this side of the line, you'll see that it won't work. All the points on this side will work. So this is a solution set to that inequality. Okay, let's talk. All right, let's look at another example of the inequality. We're going to graph this inequality. Then we got y is greater than negative 3x plus 4. So my y-intercept is at 4. So let's go ahead and graph that point. And notice I'm going to use an open circle for this point. The reason for that is because it's strictly greater than. There's no equal sign here. My slope is negative 3. So I'm going to start at this point and go down 1, 2, 3, and over 1. There's another point. Again, I could go down 1, 2, 3, over 1 more. Make another point. Since this is strictly greater than, I'm going to use a dotted line instead of a solid line. So we get this. The reason for the dotted line is because the points on this line don't satisfy this inequality. So for instance, let's look at the point 1, 1. If I put 1 in for y and 1 in for x, I get negative 3 plus 4, which is 1. Y is 1, but 1 is not greater than 1. So this point 1, 1 is not in the solution set. Any point on this dotted line is not in the solution set. The points on the line would be for when y is equal to that. So we use a dotted line for strictly greater than or strictly less than. All right, which side do we shade on? Are all these points solutions or are all these points solutions? Let's just pick one and check. Let's use a really easy one, 0, 0. So if I put 0 in for y and 0 in for x, so I'm looking at this point 0, 0. If I put 0 in for x, 0 in for y, I get 0 is greater than negative 3 times 0 plus 4. And I want to know if that's true or not. So is 0 greater than 0 plus 4? Is 0 greater than 4? It's not. So this is not a solution. And any other point you pick on this side of the line will not be a solution. For instance, let's try this point. Let's do -2, 1. That's a big no right there. Let's try -2, 1 right here. So if I put a -2 in for x and a 1 in for y, I get 1 is greater than -3 times -2 plus 4. So is 1 really greater than 6 plus 4 is 10? Is 1 greater than 10? No, it's not, so that's not a solution. So no point that you pick on this side of the line will be a solution to that inequality. Let's try one over here just to make sure it works. Let's do maybe this point. 1, no, excuse me, 2, and we'll move it up 1 to that one, 2, 3. So the point 2, 3. So 2, 3 is probably going to be a solution. Let's check and see. So if I put a 2 in for x and a 3 in for y, we get 3 is greater than, or is it greater than, -3 times 2 plus 4. So is 3 greater than, that would be -6 plus 4, which will be -2, and 3 really is greater than -2, so that's a solution. And any other point you pick on this side of the line will also be a solution. So we're going to shade in all these points over here. Any point that I pick on this side of the dotted line will be a solution. Points on the dotted line are not a solution. Points on this side are not a solution. Okay, let's talk about functions. So a function is just a relation between two sets of numbers. It doesn't have to be numbers, but usually in math it is. A relation between two sets of numbers where every element or every number in this first set matches with exactly one element in the second set. Okay, so for instance, this -2, I'm going to match it up with exactly one of the numbers over here. The -1 is going to match with exactly one element over there. Usually in math, we'll have a rule or an equation that relates these two sets of numbers. So here's an equation that's going to relate these numbers with these numbers. So our equation says for every one of these x values in this set, there's going to be a corresponding y that goes with it. And this is the rule to get it. So for the -2, for my x, I'll plug -2 in. 2 times -2 is -4, plus 1 is -3. So those guys match. Plug in a -1. 2 times -1 is -2. Plus 1 is -1. So those guys match up. If I put in a 0, I get 1. Those match. If I put in a 1, I get 3. Match. If I put in a 2, I get a 5. And you can probably see the pattern here. I get a 7. And then the 4 will go to the 9. So every element in this first set matched with exactly one element over there. Notice that some of the numbers in the second set were left out. For instance, the 0, there's nothing coming to it. But there's actually more numbers in this first set than I have listed. So anytime we have an equation in math, we're going to assume that the domain, which is this first set, is all real numbers that work in the equation. So for this equation, I'm allowed to plug in any number I want, any real number. So in this set, even though I've only listed these numbers, there's actually a lot more, like, say, 1/2. And 1/2 is in this set. If I plug 1/2 into this equation, 2 times 1/2 is 1. 1 plus 1 is 2. So the 1/2 would actually go to the 2. I could put in a -1/2. 2 times -1/2 is -1, plus 1 is 0. So that goes. I could also find maybe 1/2 is over here in the range, or yeah, 1/2 is in the range. I can find an x value that goes to the 1/2. So those all match up. Function terminology. Here we have y equals 2x plus 1. Another way of saying that, and this is function terminology, is instead of a y, excuse me, I'm going to use an f of x. So f of x is just another way of saying y. It's your y value. The x is called the independent variable. The y, or the f of x, is called the dependent variable. So this variable depends on what you plug in for x. Okay. Now, for example, if I want to know what f of negative 2 is, what this means is that my x value here is negative 2. All this is saying is plug negative 2 into the function. So f of negative 2 would be 2 times negative 2 plus 1. I'm just putting negative 2 into the x. So that would be negative 4 plus 1, that would be negative 3. Okay. Another example, f of 0 means plug 0 into the equation, and I get 1. So f of 0 is 1. This is a special value. This is called the initial value of the function. So anytime I ask for initial value, I'm wanting to know f of 0. Let's do one more. Let's do f of 5. 5 is not on our map over here, but we can put it in because 5 is assumed to be in the domain. Let's see if we can figure out where it goes. So if I put in a 5, I get that, and I end up with 11, as you could probably already guess. So that matches with 11. All right. We can write these as ordered pairs. So for instance, this first one, my x value was negative 2. My y value is negative 3. On this one, making a mess here. On this one, my x value was 0. My y value was 1. On this one, my x value was 5. My y value was 11. So here's the number I plug into the function. This is the number that it spits out. We can plot those points just like always. So negative 2, negative 3 would be here. 0, 1 would be here. And 5, 11, 2, 3, 4, 5, 3, 4, 6, 7, 8, 9, 10, 11 would be way up here. And all the little numbers in between are in there, so we can connect the dots. And we get this straight line just like always. Slope is 2, y-intercept is 1. Slope is 2, so up 2 over 1. Start at this dot, I can go up 2 over 1, up 2 over 1, and I get that. So a function is just a relation between two sets where I can plug any number I want in the domain into the function, and your function spits out exactly one number. This is an example of a linear function because it's in the form y equals mx plus b. All right, so here are 3 practice problems. I want you to pause the video, work out the problems, and then we'll go over the solutions. All right, let's have a look at these. So the first one, solve x over 5 plus 3 is equal to 7. Okay, there's one unknown in here, so our job is to figure out what value of x makes this a true statement. So I'm going to subtract 3 from both sides. That. X divided by 5 is equal to 4. So to get rid of the 5, I need to multiply both sides of this equation by 5. So I'm going to multiply this side by 5, and I'm going to multiply that side by 5. The 5's cancel, and I'm with x equals 20. Okay, let's check myself, make sure I'm right. So I'll put a 20 in for x. 20 divided by 5 is 4. 4 plus 3 is really 7. So that's true. Okay, let's solve this inequality. So I have one unknown that I need to solve for. I'm going to add 5 to both sides. 6. I need to divide both sides by 3. So I have x is less than or equal to 2. So there's my solutions. Any number that's less than or equal to 2. Let's graph that on a number line. Less than or equal to, so I'm going to use a closed circle. And I want all the numbers that are less than 2 or equal to 2. Let's check, make sure we got it right. So let's plug in a 3 and see what happens. If I put in a 3, I should get a false statement. So let's try it. 3 times 3 is 9. 9 minus 5 is 4. 4 is not less than or equal to 1, so that's not true. Let's put a 1 in. A 1 should result in a true statement. So if I put in a 1, 3 times 1 is 3. 3 minus 5 is negative 2. Negative 2 really is less than or equal to 1. So that's right. All right, let's write this in interval notation. So I want all the numbers from negative infinity all the way to 2. Infinities always have an open parenthesis. The 2 is included, so I'm going to use a square bracket. Solve this inequality. So I'm going to subtract 1 from both sides. Okay. I'm going to divide both sides by negative 2. Remember, anytime you multiply or divide both sides of an inequality by a negative number, you have to flip the way the inequality sign points. So if I divide both sides by negative 2, I'll have x is less than negative 4. Let's graph our solution set on the number line. Here's my negative 4. I want all the numbers less than negative 4. So I'm going to use an open circle and shade all those numbers. Let's check our answer, make sure it makes sense. I'm going to pick a number out here bigger than negative 4, say 0. That's an easy one. If I put in a 0, I'll have 1. It's greater than 9. That's false, so it shouldn't be shaded. Let's use a negative 5. Negative 5 should be true. Negative 2 times negative 5 is 10. 10 plus 1 is 11. 11 really is greater than 9. All right, let's represent this on a number line or in interval notation. So that's from negative infinity to negative 4. And I'm not going to include the negative 4. So I need an open parenthesis. Okay, here are some more practice problems for you. So use this equation and answer these 3 questions about it. Pause the video, work it out, and then we'll go over the solutions. All right, so first question is to find 2 solutions to this equation. And I have 2 variables, so I'm going to have an infinite number of solutions. Got 1 equation, 2 variables. I'll have an infinite number of solutions. So let's see if we can find some. Let's be clever about the numbers we can plug in and see if we can find something really easy. So I'm going to put a 0 in for x. If I put a 0 for x, 2 times 0 is 0, so that'll be gone. So then what will y have to be? Divide both sides by negative 3, and I'll get y is negative 4. So if I plug a 0 in for x and a negative 4 for y, this will be a true statement. And let's see if we can find another solution. Let's plug in a 0 for my y this time. So if I put a 0 for y, this will be gone, this term, and I'll have 2x equals 12, so x would have to be 6. So if I plug in a 6 for my x and a 0 for my y, I get a true statement. So those are two solutions. We've done what we were told. Let's just for fun, let's try to find another one. I can plug in any number I want for x. Let's do 1/2. 1/2 seems easy. If I put in a 1/2 for my x, 2 times 1/2 is 1. And so then I'll have 1 minus 3y equals 12. Subtract 1 from both sides, and I get that. Divide both sides by -3, and I get -11/3. So we're able to find an infinite number of solutions. All we have to do is plug in any number we want for x or any number we want for y, figure out what the other one has to be. But here are the two very easy ones to find. All right. Next question, write this equation in slope-intercept form. So remember slope-intercept form, the slope and the y-intercept. Slope-intercept form is y equals mx plus b. So I need to get the y by itself. So I'm going to subtract 2x from both sides. Let me start by just recopying the equation. Right, so I'm going to subtract 2x from both sides. That'll go away. I'll have -3y is equal to -2x plus 12. I'm going to divide both sides by -3. So y is equal to -2x plus 12, all divided by -3. This -3 goes with both terms, has to go with both. So if I simplify, I'll have -2 over -3, so I can write 2/3 x. 12 divided by -3 is 4. I've got that. So 2/3 x minus 4. My y-intercept would be -4. My slope would be 2/3. All right, let's graph that equation. 1, 2, 3, 4. So if my y-intercept is at -4, and notice that corresponds with what we had over here. One solution is 0, -4, 0, -4. All right, my slope is 2/3, so changing y over changing x, so I need to go up 2 and right 3. So up 2, right 3, at this point. If I went up 2 more and right 3 more, so up 2, right 3. 1, 2, 3, 4, 5, 6. 6. It's not a very straight line. Oh, that looks a little better. All right, so I got the point 60. Notice that corresponds with the solution we had over here. All right, here's another practice problem. I've given you this function f. So f of x is equal to -2x plus 7. So I want you to find these values, and then I want you to graph the function. So pause the video, work that out, and then we'll go over the solutions. All right, so f of -2, that means plug -2 in for the x. So if I put a -2 here, -2 times -2 is 4, 4 plus 7 is 11. F of -1, I'm going to plug in a -1. -2 times -1 is 2, 2 plus 7 is 9. Initial value, remember the initial value is just f of 0. It's the y-intercept. So if I plug 0 in for that, I get 7. F of 1, I'm going to plug in a 1. -2 times 1 is -2. -2 plus 7 is 5. If I plug in a 2, I'll get -4 plus 7, which would be 3. If I plug in a 3, I get -6 plus 7, I get a 1. All right, so come over here and let's graph it. My initial value is 7 here. F of 1 is 5. which is right here, and we know the slope is -2, so I know we should go down 1, 2, and over 1, so that makes sense. F of 2 is 3. And again, we went down 2 and over 1, just like we should. And since we can plug in all values of x, we will get that straight line. All right, here's the last two practice problems. So work these out, graph these two inequalities, pause the video, work those out, and then we'll go over the solutions. Okay, so the first one, notice it's greater than or equal to, so we're going to have a solid line. My y-intercept is at 3. My slope is 2, so I need to go up 2 and over 1. So if I go up 2 and over 1, this point will be 5, this will be 1. I need a solid line. So we have that. All right, now I need to figure out which side I need to shade. So let's pick a really easy point. Let's use 0, 0, and see if 0, 0 is a solution or not. Okay, so if I plug 0 in for y, and I plug 0 in for x, is 0 really greater than or equal to 2 times 0 is 0? It's 3. So is 0 greater than 3? It's not. So this side doesn't have the solutions, which means this side of the line has to contain all the solutions to that inequality. Let's just check a really easy one real quick. Let's do 0, 5. So if I plug 0 in for x, 5 in for y, so I'll have 5 is greater than or equal to 0 plus 3 is 3. 5 really is greater than 3, so that would be a solution. So all these points on this side would be solutions to that inequality. Now let's try this one. My y-intercept is at 5. I'm going to use an open circle because it's strictly greater than. My slope is -1, so I go down 1 over 1, down 1 over 1, and so on. And I'm going to use dotted line. Now all I need to know is which side contains the solutions. Let's try a really easy one. Let's put in 0, 0. So if I put a 0 for y, and I put a 0 for x, what do I get? 0 minus, or 0 plus 5 is 5. 0 really is less than 5. So that must be a solution, which means everything on this side is going to be a solution. So we will shade this side.